This video covers Part 2 of Lesson 2-6 for Secondary 1 Math, writing linear and percent inequalities and equations in one variable.
We're going to start with problem number 5. Bianca wants to donate at least $150 to her favorite charity. She earns $18.20 per hour and can donate 12% of her income. What is the minimum number of whole hours Bianca must work to have at least $140 to donate to charity? Let H represent the number of hours Bianca works. This time we're writing an inequality, then finding the solution. I'll give you about a minute to do that. Then we'll go over it together as a class. Okay, first of all, we need to represent how much she earns. So to do that, she earns $18.20 per hour. That right there shows how much she earns. Now, 12% of that goes to charity, and we want to find out how much she's spending for charity. So we're going to go ahead and multiply that by 0.12. So this whole thing right here represents how much she's giving to charity. And we want to know when this amount on the left is greater than or equal to $140 because she wants to donate at least $140 to charity. Okay, so when I do 18.2 times 0.12, I get 2.184H, and that's greater than or equal to 140. Now we're going to divide both sides by 2.184. And H is greater than or equal to 64.1. So my solution is at least 65 hours. That's the minimum number of hours that she can work to have at least $140 to give to charity. Okay, number 6. Sage ordered 8 pairs of socks online. She received a 25% discount and paid $3.50 in shipping. If her total bill was $28.76, how much did she pay for each pair of socks before the discount? Let P represent the cost of one pair of socks before the discount and shipping. Okay, I'll give you about a minute to go ahead and write your equation and find your solution before we go over it. Okay, we're going to look at two different ways to set up this equation. The first way to think about it is we have 100% for the socks minus the 25% discount plus $3.50 in shipping, and that's going to equal $28.76. So 100% of the socks is 8p. Minus 25% off of that, so 0.25 times 8p plus $3.50 in shipping equals $28.76. Okay, now 0.25 times 8p is just 2p, so I have 8p minus 2p plus $3.50 equals $28.76. Now 8p minus 2p is 6p plus $3.50 equals $28.76. Okay, before I solve this any further, I'm going to go ahead and look at the second way to write this equation. I'm just going to go ahead and jump to the next page. So remember, if I have 100% minus 25%, so I'm not paying for 25%, means I'm paying for 75%. So if 8p is 100% of the cost, if I multiply by 0.75, then that's going to tell me how much I'm paying. Plus the $3.50 equals the $28.78. So 8p times 0.75 is 6p plus $3.50 equals 28.76. And if we go back to the last page, you can see that this equation is exactly the same as that equation right there. So I'll go back to this one really quick so you can look at how I did that one. So now we need to solve the 6p plus 350 equals 28.76. Let me go ahead and clear this whole thing here. So we have 6p plus $3.50 equals $28.76. So we're going to go ahead and subtract 350 from both sides. Which gives me 6p equals $23.26. Just kidding, that's going to be $25.26. Then we're going to divide both sides by 6. So p equals 4.21. So my solution for this problem is going to be $4.21 per pair of socks. Oh, that's just getting worse as I do that, isn't it? There we go. Xavier purchased 5 hockey tickets online and paid a 7.5 service fee. If his total cost was $258, what was the price of each ticket not including the service fee? Let T represent the cost of each ticket without the service fee. Okay, I'll give you a minute to go ahead and write this equation and then solve it. Alright, so we have 100% the cost of the tickets plus the 7.5% service fee. So that gives me 107.5%. So the cost of 5 tickets is 5T plus 7.5%, which is 0.075 times the 5T, and that has to equal $258. So 0.075 times 5T, so I get 5T on the left plus 0.375T equals 258. And if I simplify, 5T plus 0.375T is 5.375T equals 258. Now we're going to divide both sides by 5.375. And we get T, squeeze this in over here, T equals 48. So we know it's $48 per ticket. Okay, that's one way to look at it. We're going to do it one more way here. So I'll let you look at that for a minute. Okay, so the other way to think about it, remember again we said that 100% plus 7.5% is 107.5%. So if I have the cost 5T and I just multiply that by 1.075 equals 258, then I get 5.375T equals 258. Divide both sides by the 5.375. And again, we get T equals 48. So our solution here is $48 per ticket. Okay, our last problem. Jeff has $86.42 in his wallet. He wants to purchase 3 shirts and a hat. Sales tax is 7.8% and a hat cost $14.75. What is the most he can pay per shirt, assuming each shirt costs the same? Let X represent the cost of one shirt. This time we're writing an inequality. Remember, the most he has in his wallet is $86.42. So I'm going to give you about a minute and a half to think about this one. This is probably the hardest one we've done so far. So think about how you would set this one up. Okay, I'm going to go ahead and go to the next page. So I need lots of room for this one. Okay, remember that we have 100% cost of the shirts plus the sales tax, which is 7.8%. Okay, so the cost of 3 shirts is 3x. Plus the sales tax is 0.078 times 3x. So that's how much Jeff is spending for the shirts. Now, he still has his hat that he's also going to buy. So plus the hat, which is $14.75, but we also need to pay sales tax on the hat. So plus 0.078 times $14.75. So there's the sales tax, and that's what he's spending, and that all has to be less than or equal to what he has in his wallet, which is $86.42. Okay, that's quite the inequalities. We're going to try and consolidate a little bit this here a little bit. So remember, 100% plus 7.8% is 107.8%. Okay, so I'm going to go ahead and erase this, and we're going to simplify this here. That was a long way to set it up. So once again, 100% plus 7.8% equals 107.8%. Okay, so I have the cost of the 3 shirts, but to find the cost of 3 shirts and sales tax, I'm going to multiply that by 1.078, plus the cost of the hat, which is 14.75, and to find the total cost of the hat and sales tax, I'm going to multiply that by 1.078, and this whole thing has to be less than or equal to $86.42. Okay, now, so 3 times 1.078 is 3.234x plus 14.75 times 1.078 is 15.9005, and that's less than or equal to $86.42. Now we're going to subtract 15.9005 from both sides. So now we have 3.234x is less than or equal to 70.5195. Now we're going to divide both sides by 3.234. And I get x is less than or equal to this really long number, which is 21.8056583. So the most that Jeff can spend is, if I look here, it's $21.80. So my solution for number 8 is $21.80 or less. That's what Jeff can spend on a shirt.
This concludes the Part 2 video of Lesson 2-6 for Secondary 1 Math, writing linear and percent inequalities and equations in one variable.